Hello everyone, good evening. So we are going to start.
Hello everyone, good evening.
So we are going to start transmission line theory, lecture number 4. In this lecture we are going to discuss reflection coefficient and impedance formula. So we are going to discuss this thing. One second. Okay. So in yesterday class, what we have studied? We have studied first lossy and lossless and lossy. What is lossless and what is lossy? What is lossy? Second thing we have studied distortionless and distortive. Distortionless and distortive. Third thing we have studied phase velocity and group velocity. Phase and group velocity. And their relationship. Fourth thing is we have studied dispersive and non-dispersive. Dispersive and non-dispersive. And third thing we have studied, fifth thing we have studied lossless, distortionless. Lossless plus distortionless and lossy plus distortionless. So these all things we have studied in the previous class. These all things we have studied in the previous class. Next topic what we have going to cover. First point is we are going to cover that impedance and if time remains then we will going to cover that reflection coefficient. Okay, so we are going to cover two things, impedance and reflection coefficient. Okay, so our first point is transmission line with load. Actually we have it right now in all three classes we have studied only transmission line, about transmission line, okay, how much transmission have loss, lossy, lossless, something like that. What is the phase velocity, what is the group velocity, what is the propagation constant, what is the characteristic impedance of that transmission line. But after that, today we are going to discuss what? Today we are going to discuss the transmission line with load. That means the main application of the transmission line, because only transmission line cannot be will not be used. Transmission line having load will be used. So our topic is transmission line with load. So this topic will be continue for last class, up to last class. So transmission line with load. In this topic what we are going to study in this topic, in this parameters, we are going to study first of all impedance. In this topic we are going to first of all study impedance, then second thing is reflection coefficient. Third thing is matching, mismatching, matching and mismatching condition. And fourth thing is power in transmission line. Fifth thing is we are going to study VSWR, voltage standing wave ratio, or we can say that standing wave ratio. Standing wave ratio. 6th point, we are going to study transient in the transmission line, that means transient condition. 7th point, S parameter. 8th point, impedance matching. 8th point, impedance matching. Impedance matching. And 9th point, Smith chart. Smith chart. And 10th point, miscellaneous, if something remaining, miscellaneous. So these are the topics related to transmission line with load, and from this topic they will ask the question. This year they have asked the question from VSWR. This year they have asked the question from VSWR. And second, impedance. So in 2024 they have asked the question from VSWR and impedance. So these all our topics are important. So our tough topic is only transient. You have to study very carefully transient and S parameter. These two topics are very learning process, means this one is very tricky topics, so we have to study carefully. Okay, then we are going to study, first thing is transmission line with load. First thing we are going to study transmission line with load. So what is happened here, I am not going to derive anything, because this derivation neither asked in GATE exam, or this derivation neither asked in ECE exam. So I am not going to derive anything. So this is our transmission line. This is our transmission line. This is our transmission line. So this is our first part of the transmission line, and this is our second part of the transmission line. So this is only one transmission line. It is not we are using two transmission line. This is inner conductor, so this is outer conductor. This is outer conductor, so this will be inner conductor. Okay, so there is no difference that they are different, something like this. No, they are not different. Okay, so here what will happen, this one is connected with load, this transmission line is connected with load, okay, and there is a source also, so one load and one source, so this one is connected with load. Okay, so we have, and there is a source, there is a source, the source will be written as ZG and the load will be written as VG, will be written as, this one is VG, okay, so this one is VG. Generator voltage and generator load, and the characteristic impedance of this transmission line is Z0 and the load impedance is ZL. Then we are going to discuss about, there is a one voltage wave traveling in this direction, there is an voltage wave traveling in this direction, so that is forward voltage and it is the function of X, and there is a voltage wave traveling in this direction, that is reverse voltage, it is also function of X. These two voltage travels in same transmission line, so they will add up or they will subtracted according to phase. So this one is the voltage, this one is forward voltage and this one is forward current, so reverse voltage. And if it is forward voltage, then there is forward current also. If it is forward current, reverse current voltage, there is reverse current also. So we have what, there is forward voltage VFX, there is forward reverse voltage VRX, so this is forward voltage. So how it is written in, how it will be written, so it will be written like this. At load we will consider X is equal to 0 and at source we will consider X is equal to L. So length of the transmission line is L. So always we will take, always means always we will take that at load X is equal to 0 and at source X is equal to L, except transient. In transient we will take X is equal to 0 and X is equal to L. Why we are taking X is equal to 0 at load? Because we can measure load voltage, we can measure load current, so it is very important. So we can measure load voltage and load current. That means if there is an electric supply here, so I can measure load voltage across this light, across this tube light, so I can measure the load voltage and load current, but I cannot measure the load voltage or load current, source voltage or source current, because this is generation side, means this is at power station, so this one will not be measured, but this one will be measured. So we are measuring only load voltage and load current, and we describe about transmission line. So it is important here to understand load voltage and load current. So we have to consider X is equal to 0, because we are calculating load voltage and load current here. Okay, second thing is that we can measure the mathematics will be very easy. The mathematics will be very easy for this case. Good afternoon, and they are saying antenna will also be taught here. Antenna will be taught here after some time. After some time antenna will be taught, but right now I am going to teach transmission line only. After some time means in August, September, when will be free, I will teach second term antenna. Second my lecture will be antenna. So in these lectures I will teach, in this series I will teach transmission line, and in next series I will teach antenna. Okay, so this is the load voltage, and load I will consider x is equal to 0, and at source I will consider x is equal to L. Second thing is that I am going to consider that I am going to consider, so in transient this one x is equal to 0 and x is equal to L in transient only, and everywhere else x is equal to 0 means load, x is equal to L means source. So this one is the at x is equal to x. So x is equal to x, we are going to measure forward voltage, we are going to measure reverse voltage, we are going to measure forward current, we are going to measure reverse current, and we are going to measure for impedance, and we are going to measure voltage, we are going to measure current, and we are going to measure reflection coefficient. So these all things we are going to measure at this point. And second thing is that we are going to measure all these things, yes sir, but I am teaching only for understanding purpose these all things. After that I will teach for cramming purpose, for remembering purpose. But right now I am writing some formula, so you don't have to remember that formula, you don't have to cram that formula, you have to only see, only you can just watch and understand the topic. Then after we can understand from impedance onward, you have to remember the formula or you have to derive the formula. But right now the equation I am writing is not important. I can derive this equation, but there is no need to derivation, because they are not going to ask in ECE exam, they are not going to ask in the GATE exam, they are not going to ask in anywhere else, in interview also. So this derivation is not important here, so I am not going to derive anything. Okay, so first of all I am going to name this all things. This name is, first one is name is forward voltage. This now for name is forward voltage at a distance x from the load, at a distance x from the load. So this is forward voltage at a distance x from the load. Always measure the distance from load, always measure the distance from load. Second is reverse voltage. Just name, you will understand the whole things. So I am going to name all these things. You don't have to remember the formula of all things. Okay, at a distance from the load. Yes sir. And this one is IFX, IRX. Next thing is VR. Vx is, it is important to understand, because from here I will derive this what VSWR. So it is important to understand. So there is the voltage of forward voltage and there will be reflected voltage. So at this point there is a forward voltage also and there is a reflected voltage also. So at this point what will happen? At this point there is two types of voltages are present. One is forward voltage, second one is reflected voltage, or because of that they are known as standing wave voltage. They are known as standing wave. So always remember, forward wave plus reflected wave is equal to standing wave. Forward wave plus reflected wave is equal to standing wave. So this one is a standing wave, this one is a standing wave, this is forward wave, and second one is reverse wave. Reverse wave. Why you are writing wave? You can write voltage also, there is no problem. But in transmission line, the voltage and current are exist in a wave form. So it is a standing wave. So because of this we study VSWR. Okay. So then we have IFX. IFX is forward current. It is forward current at a distance x from the load. At a distance x from the load. At a distance x from the load. And second one is IRX. IRX is reverse current. It is reverse current at a distance x from the load. At a distance x from the load. And there is a standing wave of current also, that means IFXX plus IRX. So this is a standing wave of current. So this is a standing wave of current, this is a standing wave of voltage. So it is known as standing wave. Okay. Then after we are going to study what is I formula for IFX, what is the formula for VFX, what is the formula for IX. Don't remember this formula. I am saying always don't remember this formula. If you are going to remember this formula, you will be not get benefited. So don't remember this formula. It is only for understanding purpose. So VL by 2ZL, VL by 2ZL, 1 second. Yeah. So VL by 2ZL, ZL plus Z0, e to the power plus gamma x, and ZL minus Z0. So this is our forward voltage. This is our forward voltage. And same thing is VRX. VRX is VL upon 2ZL, ZL minus Z0, e to the power minus gamma x. So we can write down Vx. Don't remember all this formula. VL is equal to Vx is equal to ZL and ZL minus Z0 VR plus VF. So VR plus VF is our voltage. Then I will take common VL upon 2ZL, ZL plus Z0, e to the power. So we can write in this form. Okay. Then after we are going to discuss second thing is what is reflection coefficient of voltage. So reflection coefficient of voltage is VRX upon VFX. So it is known as reflection coefficient of voltage. So this is known as reflection coefficient of voltage at a distance x from the load. Of voltage at a distance x from the load. At a distance x from the load. From the load. Okay. So this is the formula for reflection coefficient of voltage. So what is the formula for reflection coefficient of voltage? Reflection coefficient of voltage formula is ZL minus Z0 divided by ZL plus Z0 e to the power minus 2 gamma x. This is the reflection coefficient voltage. Don't remember this formula. I will give summary. That thing you have to remember only. Okay. Second thing similarly we can write for current also. We can write for current also. So for current, what will happen for current? This one is for current. So for current it will be, so current, forward current will be divided by Z0, so it will be forward current, and divided by Z0 it will be reverse current, but this will be Z0 minus ZL, Z0 minus ZL, so it will be Z0 minus ZL. So divided by Z0, standing wave current, Z0 minus ZL. So our reflection coefficient of current will be, so reflection coefficient of current will be IRX upon IFX, and this is the reflection coefficient of current at a distance x from the load, and reflection coefficient of current will be Z0 minus ZL, Z0 minus ZL. So this is the forward current, this one is the reverse current, this one is the standing wave of the current, and this one is the reflection coefficient of current. So this reflection coefficient of current is IRX upon IFX, IRX upon IFX, and it will be Z0 minus ZL upon Z0 plus ZL e to the power minus gamma x. So this is for reflection coefficient of current. So we have done for reflection coefficient of voltage, we have done for reflection coefficient of current. Then we are going to discuss about what? Impedance, Zx, impedance at a distance x from the load, impedance at a distance x from the load. So impedance at a distance x from the load. This is the thing. So impedance, how we will calculate? Impedance we will calculate steady state voltage Vx upon steady state current Ix. So Vx is VL upon 2ZL and ZL plus Z0 e to the power minus plus gamma x, and ZL minus Z0 e to the power minus gamma x, divided by VL upon 2ZL Z0 and ZL plus Z0 e to the power gamma x, and Z0 minus ZL e to the power minus gamma x. You don't have to remember this formula. All these things you don't have to remember. So Zx will be VL will be cancelled out, ZL will be cancelled out, so it will be Z0, and I will take common ZL, so it would be e to the power gamma x plus e to the power minus gamma x, and this one is Z0 e to the power gamma x and minus e to the power minus gamma x. And then after we have ZL, ZL is e to the power gamma x minus e to the power minus gamma x plus Z0 e to the power gamma x plus e to the power minus gamma x. So in this case ZL will be positive, Z0 is positive negative, here ZL is positive negative, Z0 is positive. So write down, I have written down like this. Then after I will divide by 2, this one by 2, this one by 2, and this one by 2. So e to the power theta, e to the power minus theta divided by 2 cos hyperbolic theta, e to the power theta, e to the power minus theta, minus e to the power minus theta sin hyperbolic theta. So they are hyperbolic function. They are hyperbolic function. So we will write at cos hyperbolic gamma x plus sin hyperbolic gamma x, and we can write Z0 sin hyperbolic ZL, ZL sin hyperbolic gamma x and Z0 cos hyperbolic gamma x. I will take cos hyperbolic gamma x common, so it will be tan, it will be tan. So our formula for Zx is ZL plus Z0 tan hyperbolic gamma x and divided by Z0 plus ZL tan hyperbolic gamma x. So this is the formula for what? Impedance. This is the formula for impedance at a distance x from the load. So what we have derived? We have derived reflection coefficient of current at distance x from the load. We have derived reflection coefficient of voltage at a distance x from the load, and we have derived reflection coefficient at a distance x from the load. So these all things we have derived right now. Then after, what we will do? We will go for do some more analysis. That means our summary part. This part you have to remember each and every point so that you can solve the questions of GATE. So it is very important to revise all the points, to remember all the points, or to understand all the points. So from here the question will be asked in this case. So they will ask in case of lossless, in case of lossy. So I am going to derive everything for lossless, for lossy, everything I am going to derive this, so that you will understand the points. First point is gamma is equal to alpha plus j beta. So this is for lossy. And second point is gamma is equal to j beta, means alpha is 0. This is for lossless. So in case of lossless, I will replace gamma with j beta, and in case of lossy, I will replace gamma with alpha plus j beta. Okay. Third point is I am going to discuss is gamma v. Gamma vx is equal to zl minus z0 and zl plus z0. Yes sir. And e to the power minus 2 gamma x. E to the power minus 2 gamma x. Yes, it should be minus 2 gamma x. So zl minus z0, zl plus z0, e to the power minus 2 gamma x. Okay. Okay. So it can be written as also in case of lossy. In case of lossy, what you will write down? In case of lossy, you will write down gamma vx is equal to zl minus z0 upon zl plus z0 and e to the power minus 2 alpha x minus j2 beta x. Yes, this is in case of lossy. And in case of lossless, what it will be? In case of lossless, gamma vx is equal to zl minus z0, zl minus z0, zl plus z0, and it will be written as only alpha will be 0, so 2 beta x. It will be written as only 2 beta x. So this is the for reflection coefficient of voltage. Similarly, reflection coefficient of current will be written as gamma ix z0 minus zl divided by z0 plus zl, and it will be written as e to the power minus 2 gamma x. So gamma ix is equal to gamma ix for lossy is equal to, so for lossy transmission line it will be written as, gamma ix is equal to z0 minus zl and z0 plus zl. Yes sir. And e to the power minus 2 alpha x into e to the power minus 2 beta x. E to the power minus 2 alpha x into e to the power minus 2 beta x, j2 beta x. Okay. So I will write it down like this. E to the power minus 2 alpha x, e to the power minus j 2 beta x. Yes sir. And in case of lossless transmission line, alpha will be 0, so gamma ix will be written as z0 minus zl divided by z0 plus zl and e to the power minus j to beta x. So this is the formula for gamma ix and gamma vx. Then after we can understand fifth point. Fifth point is our what is the relationship between gamma vx and gamma ix? It is minus times. That means if there is gamma vx is positive, then gamma ix is negative. If gamma ix is negative, then gamma vx is positive. So there is a minus times relation. You can see it here. You can see it here. It will be ZL minus Z0 and it will be Z0 minus ZL. So there is a negative times relationship between them in third point and fourth point. So gamma Vx is equal to minus times of gamma Ix. So you have to remember this point only. You have to understand this point only. Okay. Then sixth point is I am going to give you after that summary. That means there is a perfect example analysis so that you will remember everything. Then we have Zx. Zx is equal to, I will write down cos hyperbolic x. So cos hyperbolic theta is equal to, cos hyperbolic theta is written as, what is it is written as? Cos hyperbolic theta will be written as e ka power theta plus e ka power minus theta divided by 2. Okay. Then I will ask what is cos hyperbolic? J theta will be written as. So in case of j theta, it will be j theta. It will be minus j theta divided by 2. So it is something like cos theta. So cos hyperbolic j theta will be represented as cos theta, because in place of theta I will replace j theta. I will replace j theta. Similarly, sin hyperbolic theta is e to the power j theta, e to the power theta minus e to the power minus theta divided by 2. So e to the power theta minus e to the power minus theta divided by 2. Then I will ask what is sin hyperbolic j theta? Sin hyperbolic j theta, it will be e to the power j theta and e to the power minus j theta divided by 2. And then after I can multiply with j and divide with j. So it will be j sin theta. So sin hyperbolic theta j theta is equal to j sin theta. Cos hyperbolic j theta is equal to cos theta, and tan hyperbolic will be represented as. So tan hyperbolic j theta will be represented at. So tan hyperbolic j theta will be represented at cos sin hyperbolic j theta upon cos hyperbolic j theta, and sin hyperbolic j theta will be represented as j sin theta, and cos hyperbolic j theta will be represented as cos theta. So it will be j tan theta. So cos hyperbolic j theta cos theta, sin hyperbolic j theta j sin theta, and tan hyperbolic j theta will be j tan theta. Similarly, cot hyperbolic j theta will be equal to, cot hyperbolic j theta will be equal to, so cot hyperbolic j theta will be equal to cos hyperbolic j theta divided by sin hyperbolic j theta. Yes sir. And it will be written as cos theta divided by j sin theta. Yes sir. And it will be written as minus j cot theta, because 1 by j is minus j. So it will be minus j cot theta. So it is very easy. So we have understand tan hyperbolic j theta, cos hyperbolic j theta, sin hyperbolic j theta, and tan hyperbolic j theta. We have understand everything. Then after we are going to understand seventh point. Seventh point is Zx, impedance at a distance x from the load. It will be ZL. It will be ZL plus Z0 tan hyperbolic gamma x divided by Z0 plus ZL tan hyperbolic gamma x. So this is for lossless or lossy. This is for lossy transmission line. This is for lossy transmission line. Okay. Then what about the for lossless transmission line? In case of lossless transmission line, in case of lossless transmission line, what will happen? So in case of lossless transmission line, gamma is equal to j beta. Gamma is equal to j beta. So our zx will be equal to z naught and zl plus z naught tan hyperbolic, and gamma will be replaced as j beta. Gamma will be replaced by j beta. Similarly, z naught, zl, tan hyperbolic, and gamma will be replaced by j beta. So j beta. So it will be tan hyperbolic j theta is j tan theta. Tan hyperbolic j theta is j tan theta. So z naught, zl plus j tan theta tan beta x, and divided by z naught plus j zl tan beta x. So this is the formula for which part? Zx. This is the formula for Zx, impedance at a distance x from the load. So this is the formula for Zx. Then we are going to study the reflection coefficient in terms of impedance and impedance in terms of reflection coefficient. So what we are going to study? 9th point. I am going to derive this point, but you have to remember that I will ask if Zx. So you have to remember Zx is equal to 1 plus gamma x and divided by 1 minus gamma x and e to the power and into z naught. You can write it down. So you remember like this, you can remember like this, or you can remember like this: gamma x is equal to zx minus z naught divided by zx plus z naught. So you will remember like this also. So you remember like this formula also and this formula also. Second thing is 11th point. How you will derive this? How you will derive this equation? So from basic I will derive this: zx is equal to vfx upon vrx upon vx upon ix. Vx upon ix. So Vx upon Ix is nothing but Z naught and ZL plus Z naught. Yes sir. E to the power gamma x. Yes sir. ZL minus Z naught. Yes sir. E to the power minus gamma x. Yes sir. And divide by ZL plus Z naught. E to the power gamma x and Z naught minus ZL. E to the power minus gamma x. Yes sir. So I will write it down: Z naught 1 plus ZL minus Z naught divided by ZL plus Z naught. Yes sir. And e to the power minus 2 gamma x. So I have taken this common, divided by, I have taken this common also, so 1 and minus ZL minus Z naught, because it is written as Z naught minus ZL, so I will take common minus, so ZL plus Z naught e to the power minus 2 gamma x. Yes sir. So this one is known as gamma reflection coefficient, this one is known as reflection coefficient, so it will be written as Z naught 1 plus gamma x and 1 minus gamma x. And after applying componendo dividendo, you will get this. So you will get this formula from applying componendo dividendo. So we have derived this formula. So we have known this formula. Then we will study it later, but right now write this formula. 12th one is, this one is VSWR. VSWR is equal to 1 plus mod gamma 1 minus mod gamma. I will describe how this formula is VSWR. What is VSWR? So I will describe it later, but right now you can write this formula. So VSWR is equal to 1 plus gamma and divided by 1 minus gamma. So these are the all things you have studied. Then after we are going to study the two different things. That means first one I am going to teach you. Second one for lossless and lossy. So here I am going to teach you about lossless transmission line. Which type of transmission line? Lossless transmission line. Lossless transmission line. And in this case, in second part, I am going to discuss lossy transmission line. Lossy transmission line. So we have studied lossless also, we have studied lossy also. Yes, so both we have studied. So what about lossless? You have studied lossless, alpha is equal to 0, and second thing, beta is equal to omega under root LC. Yes sir. And third thing, gamma is equal to j beta. Yes sir. And fourth thing, what you have studied? You have studied gamma x is equal to ZL minus Z naught, ZL minus Z naught divided by ZL plus Z naught, e to the power minus j 2 beta x. Yes. Then fifth point, at x is equal to 0. X is equal to 0 means what? X is equal to 0 means at load. X is equal to 0 means at load. X is equal to L means at source. So reflection coefficient at load is gamma L. Reflection coefficient at load is gamma L. That means x is equal to 0. And reflection coefficient at source is gamma in. Gamma in, that means input reflection coefficient at x is equal to L. So at load x is equal to 0, at source x is equal to L. So there are two types of reflection coefficient. First one is at load. So at load x is equal to 0. That means gamma L, ZL minus Z naught, ZL plus Z naught. So this is our formula for gamma L. And this one is x is equal to 0. If I will put x is equal to 0, it will become 1. It will become 1. Then after what we will do? Then after we will discuss input reflection coefficient. Then after we will discuss input reflection coefficient 6. That means reflection coefficient at source. Reflection coefficient at source means gamma L. That means ZL minus Z naught divided by ZL plus Z naught and e to the power minus j2 beta L. Yes sir. So I can write it down, gamma L is equal to, so gamma in is equal to, this one is gamma L, reflection coefficient at load, minus j2 beta L. Yes sir. And gamma x will be equal to, so gamma x would be equal to gamma L e to the power minus j2 beta x. If you are calculating at x is equal to L, it will be gamma in. If you are calculating at x is equal to 0, it will be reflection coefficient at load. If you are calculating at a distance x from the load, so it will be gamma L e to the power minus j2 beta x. Ninth point is very important, that is magnitude of gamma x. So magnitude of gamma x is equal to magnitude of gamma n. So our VSWR will be equal to 1 plus mod gamma x and divided by 1 minus mod gamma x, and mod gamma x is equal to mod gamma L. So it will be mod gamma L 1 minus mod gamma L. Yes sir. So this is the formula for VSWR. Then after what we will discuss? We will discuss impedance. So for impedance, what it will be? So 11th point, impedance, what it will be? So impedance is equal to Zx, yes sir, Z0, yes sir, ZL plus JZ0 tan beta x, yes, and Z0 plus JZL tan beta x, yes sir. So what will happen? This is our transmission line, yes sir, and this is our transmission line, yes sir, and this is our load, yes sir, and we have this one x is equal to 0, this one x is equal to 0, and this one x is equal to L, and at this point gamma L, at this point gamma N, at this point gamma X, yes sir, at this point ZL input impedance, here input impedance, and here Zx. So Zin will be equal to, I will put x is equal to L, Zin will be equal to, I will put x is equal to L, so Z0 and ZL plus JZ0 tan beta L divided by Z0 plus JZL tan beta L. So this is the formula for impedance. This is the formula for impedance. Okay. So input impedance formula we have derived. Then we have 12th point. 12th point is if our ZL is equal to 0, that means short circuit input impedance. If ZL is equal to 0, what will happen? If ZL is equal to 0, what will happen? So there is something happen. So we are going to discuss that point, 12th point. So 12th point is if ZL is equal to 0. So ZL is 0, that means short circuit. So ZL is equal to 0, 0. You will put it here 0, 0, 0, JZ0, 0, 0. Z0, Z0 will be cancelled out. So our short circuit impedance will be Z0, JZ0 tan beta L, JZ0 tan beta L. This is short circuit impedance. This is short circuit impedance. Yes sir. So you will put ZL is equal to 0 in equation 1, you will get short circuit impedance. And second thing is if ZL is equal to infinite, what will happen? If ZL is equal to infinite, there is something happened. I will discuss in the next page. If ZL is equal to infinite, then what will happen? So ZL is equal to infinite, then we have to derive for ZL is equal to infinite. That means open circuit. So ZL is equal to infinite, it will be ZOC is equal to Z0. I will take ZL common, 1 plus J Z0 upon ZL tan beta L, yes sir, and second one is Z0 upon ZL plus J tan beta L, yes sir. Then what will happen? ZL is infinite, open circuit, so in this case it will become 0, in this case it will become 0, so 1 plus 0 and this one is something, so our answer will be JZ0 cot beta L. So it will be written as Z0 and downside is the J tan beta L. So J will be top, so it will be minus J and Z0 cot beta L. So it is minus JZ0 cot beta L. This is the formula for open circuit. This is the formula for open circuit. Then we have 14th point. Then we have 14th point. What we have 14th point? 14th point is, what is the connection with ZOC and ZSC? What is the connection with ZOC and ZSC? So ZOC is equal to ZSC is equal to JZ0 tan beta L. Yes sir. And ZOC is equal to minus JZ0 tan beta L. And if we multiply ZSC into ZOC, you are getting Z0 square. Why? J square minus 1 minus plus, and this one tan and cot, it will be 1. Tan and cot multiply, it will be 1. So it will be ZOC. So Z0 is equal to under root ZSC into ZOC. Yes sir. Then we have last formula, 15th, that is Zin is equal to 1 plus Zx is equal to, so we are going to derive in the next page. So this is the formula for relationship between ZSC and ZOC. Then we have last point, 15 point is Zx is equal to 1 plus gamma x and 1 minus gamma x into Z0. Yes. So we have 16. Zn is equal to, so I will take gamma A from input side, 1 minus gamma in, 1 plus gamma in into Z0. Okay. Or for ZL is equal to, so for ZL is equal to, I will take reflection coefficient at load, so 1 minus gamma L into Z0. So these are the formula for that thing. At a distance x, reflection coefficient at a distance x, input side, reflection coefficient input side, load, reflection coefficient at load. These are the all formulas. Then we have lossy transmission line. Lossy transmission line, what we have? First thing is alpha. Alpha is equal to under root Rg. Yes sir. R by Z0. Yes sir. G into Z0. Yes sir. And R into under root C by L. Yes sir. And G into under root L by C. Yes sir. Second thing is beta. Beta is equal to omega under root LC or 2 pi by lambda. 2 pi by lambda. Okay. Third thing is gamma. Gamma is equal to alpha plus G beta. Yes sir. Fourth thing is reflection coefficient. Reflection coefficient will be written as ZL minus Z0, ZL plus Z0, and e to the power minus 2 alpha x, e to the power minus j2 beta x. Yes sir. At load, it will be x is equal to 0 at load. At load, I will put x is equal to 0, 1, x is equal to 0, 1. So gamma L will be equal to ZL minus Z0, ZL plus Z0. So this is our gamma L. This is our gamma L. So gamma L formula for lossy and lossless, both are same. For lossy and lossless, both are same. Okay. Then gamma N. Gamma N is equal to, we have gamma N is equal to gamma at a distance L. That means ZL minus Z0, ZL plus Z0, and e to the power minus 2 alpha L, e to the power minus j2 beta L. Yes sir. Then we have 8 point, 6 point, 7th point. Gamma in will be written as ZL minus gamma L e to the power minus 2 beta L, e to the power minus 2 alpha L, e to the power minus j2 beta L. Yes sir. Then 8th point is gamma x, gamma x is equal to gamma L, and e to the power minus 2 alpha L, e to the power minus j 2 beta x. Then we have magnitude of gamma x. Magnitude of gamma x is equal to magnitude of gamma x and e to the power minus 2 alpha x. Yes sir. So this one and this one are different. Yes sir. So in case of VSWR, what it will be? So many people will do like this only. For lossy transmission line, VSWR will change. For lossy transmission line, VSWR will change. But no one care about this. And if exam they will ask, then there will be problem. They will ask at load, so I will take x is equal to L. They will ask at some distance x, so I will take that distance x. So this is very, very important formula for VSWR. Many people will use this formula, but that formula will be wrong. You can use this formula. Okay, then 11th point. 11th point is Zx. Zx is equal to Z0 ZL plus Z0 tan hyperbolic gamma x. Yes sir. And divide by Z0. Yes sir. Plus ZL tan hyperbolic gamma x. Yes. And this is the condition for our load. Similarly, condition for this one also. Okay. And this is the condition for Zin. Yes sir. This is the condition for Zin. So Zin will be at a distance L. Zin will be at a distance L. So I will write it down Zin. And it will be at a distance L. So it will be gamma L. It will be at a distance L. So it will be gamma L. So this is the formula for Zin. This is the formula for Zin. Okay. Now we have Zin. Yes sir. Zin is equal to what? So it will be Z0. Yes sir. ZL plus Z0 tan hyperbolic gamma L divided by Z0 plus ZL tan hyperbolic gamma L. Yes sir. And we have transmission line where it is short circuit. Where it is short circuit. So in case of short circuit, what will happen? In case of short circuit, I will put ZL is equal to 0. So Z0 tan hyperbolic gamma L and divide by Z0 plus 0. So this Z0 and this Z0 will be cancelled out. So ZSC formula will be Z0 tan hyperbolic gamma L. Tan hyperbolic gamma L. Yes sir. So this is formula for ZSC. Similarly, for ZOC, what you will do? For ZOC, same thing. So for ZOC, Zin is equal to Z0. Yes sir. ZL plus Z0 tan hyperbolic gamma L and divide by ZL Z0 plus ZL tan hyperbolic gamma L. There is open circuit. There is open circuit. In that case, what will happen? In case of open circuit, it will be ZOC Z0 1 plus Z0 by ZL tan hyperbolic gamma L and Z0 by ZL plus tan hyperbolic gamma L. If ZL is infinite, this will become 0, this will become 0. So ZOC is equal to, ZOC will be equal to Z0 upon tan hyperbolic gamma L, that means Z0 into cot hyperbolic gamma L. So this is the formula for ZOC. This is the formula for ZOC. Then we have derived ZOC. Then we can find out a relationship between ZOC. We can find out a relationship between ZOC. Yes, sir. So we can find out relationship. So what is the relationship? So here ZSC is equal to Z0 tan hyperbolic gamma L, and ZOC is equal to Z0 cot hyperbolic gamma L, and ZSC into ZOC is equal to Z0 square, that means Z0 is equal to under root ZOC into ZSC. Okay, so this formula is valid for lossless transmission line and lossy transmission line both. This is valid for lossless and lossy transmission line both. Then 15th point, there is no change in the formula. So we can write 15, 16 and 17, the all formula are same. So tomorrow we will study. So today I am end of this class. So tomorrow we are going to study what? We are going to study impedance, that means quarter wavelength impedance, lambda half wavelength impedance, lambda by 8 wave impedance, short circuit impedance, open circuit impedance, series resonance, parallel resonance, all that thing stuff. Okay, so here impedance and transmission line with load we have covered. So we have covered what? Transmission line with load. So this is the basic class for transmission line with load. This class is very important for which part? For understanding the next all class. This is the Unity app you have to download, and this app is very useful, and you can join Sonu Sir PW for any help. Thank you everyone.